So time in Einstein's theory of general and
Special.
relativity is something that can be dilated. Einstein had this concept of time dilation where he figured out that if you are traveling close to the speed of light or near a very massive object like a black hole, time actually starts to slow down. So in our scientific understanding of time, we are at a point where we can see that time is not so one-dimensional and linear. It can sort of stretch and shrink. But there's still no subjective quality to time. We only understand time in this quantitative way. And in fact, since the scientific revolution, we sort of let go of any sense that we should try to integrate any qualities or subjectivity into our understanding. We sort of prioritize this objective look at things, which quantum mechanics actually then eventually came to challenge. So when we get to Heisenberg here with Einstein in the early 20th century, we have this revelation that we cannot know certain quantities simultaneously. Essentially, the act of measuring a particle necessarily alters its ontology, the nature of the thing that you're observing. So our act of observation and measurement affects how much we're able to understand about the particle itself. This is the uncertainty principle, that when you try to measure the position and momentum of a particle, the more you know about one, the less you know about the other. And although quantum mechanics gave us this particle wave duality, that a particle can also be understood as a wave and waves can also be understood as particles, we cannot observe them to be both simultaneously. Observing the particle wave particle, wavicle, there's different words people say, actually collapses its nature and it becomes a particle once we observe it. Specifically, the more we narrow in on its position.